Greetings. This is a short video meant to show you how to interpret the output that SPSS generates for a one-sample t-test and for a two independent samples t-test. In the first test, we'll look at the hypothesis that the sample mean is not equal to 69. Here's the hypothesis. As you can see, H0 states that the sample mean equals 69, and H1 states that it's not equal to 69. Of course, this means that we have a two-sample t-test. Here's the output from after running the procedure. As you can see, SPSS produces three tables. The first provides some basic statistics about the sample. The mean, the standard deviation here are the most relevant ones. Our test value 69 is pretty close to the sample mean, but the real question here is the difference between the sample mean and the test value statistically significant? The answer to that is in the second table. SPSS doesn't know whether we're conducting a one-tailed or a two-tailed test, so it gives us the probabilities for both. As you can see, for the two-tailed test, it turns out that the differences are just barely statistically significant at a value of 0.048. I asked SPSS to also compute effect sizes, and the values we want to look at, the value we want to look at here is the point estimate for Cohen's d. At a value of -0.2, it appears that the effect is only a very small one. It's worth pointing out that the sign of the point estimate doesn't really mean anything. Remember that the numerator for Cohen's d is simply the difference between the sample mean and the test value. The negative value here just indicates that the test value was subtracted from the sample mean rather than the other way around. Okay, let's look now at the output from an independent sample t-test. First, of course, the hypothesis. Here we have H0 being that the mean for the males is the same as the mean for the females, and for H1 we have the mean for the males is different than the means for the females. Let's take a look at the output now. Again, we have three tables, although they look a bit different. The group statistics table is just like the one we saw in the one-sample t-test. We have some basic descriptive information about the two different groups that we're comparing. The second table is similar to the one we saw in the previous example, except that it includes some additional information. Remember that one of the assumptions for the independent samples t-test is that the variances of the two samples have to be about equal. These first two columns conduct a Levene's test to find out whether or not this assumption has been met. The hypothesis for this test is that the variances are in fact equal, and the fact that the hypothesis is rejected is noted by the fact that the significance of the Levene test is given at 0.004. Because these variances are not equal, we have to read the second row of the table, which is labeled equal variances not assumed. All you have to understand here is that SPSS computes the t-value somewhat differently if the assumption of equal variances is not met. In this case, though, it doesn't make any difference in the outcome of the test. Based on the analysis, we can reject the null hypothesis that the scores for men and women are the same. The third table, again, gives us the effect size, just like in the one-sample test. The value for Cohen's d is 0.907, which indicates a strong effect.